Okay, we have section 4.3, question P25, and kind of a grave problem here, something, again, authentic data, but more sobering data. We have neonatal mortality, so dying within the first 7 days of life, and you can imagine how traumatic that would be for a family where the woman has carried the baby full term. So keep in mind too that these 44 cases here, even though we're analyzing them as data, each one of those 44 represents some baby who has died and the family and the community that has mourned their loss. So not to get too morbid there at the beginning, but I do want to keep in mind that these data are connected to authentic life events, and that's why it's important that we do understand how to analyze and read data and create. So we have this case and control matching. First of all, what is going on here? So we have a situation where we want to look at a cause and effect. And as you've read, the best way to do that is through a true experiment. However, this would mean randomly assigning babies to low birth weight in this case, which wouldn't even really make sense. It's not something that we could really do, or if we could, we certainly wouldn't want to. That would be very unethical. So because we can't get at that experimental source of cause, what we're trying to do is set up a study where we take out most of the variation. So we're taking each baby who died, and in some senses this is an observational study, and we'll get to that in a second. But it's a very well-designed one. So we're taking each baby who died and matching them with 5 controls. So babies who did not die. And if our baby had low birth weight, we want to match it with a baby who also had low birth weight but survived. So with these 281 babies, let's get a sense of what this chart is. Now, in a lot of these types of classification tables, we have totals in both directions, and they'll add up to the total number will be at the bottom right of the chart. So there's that 281 that we're seeing in the total babies. So we see here, what's this 44? Again, these are the 44 babies who died. Of those 44 babies who died, 28 had low birth weight and 16 did not have low birth weight. So it looks like actually when they were matching them, maybe they didn't match based on weight. No, it looks like they were based on when the baby was born. So for each case who died, we had two of the babies that were born immediately before and 3 after. So this would probably reduce some of the things based on potentially weather, disease that was going around the hospital, potentially the medical staff that was working at that particular hospital. It would take out some of that variability by getting 6 babies in a row, and we're looking at the one who had died in the middle. So anyway, we have these 44, 237. These babies did not die. Of these babies that did not die but that were matched with a baby who died, 29 of them did have low birth weight but still survived. 208 did not. So the first question we're asked is, what is the response variable in the study? That's the outcome. That's what we're looking at, the result that we're concerned with. And the result here is death. This is what we're concerned with as an outcome. So does a baby die or not within that first 7 days? And what would be explaining that death? What's the predictor? In a sense, what is the treatment? Although we don't usually use treatment in this case because we're not the ones controlling it. It's beyond our control. But it's the same, it takes the same role in the study as a treatment. But that explanatory variable that may be causing death is the low birth weight. So this is our explanatory or predictor variable. This is our outcome or response variable. So is it a survey, observational study, or an experiment? Observational study. So why is that? Well, we know that experiment has very rigid set of requirements. We need to have randomization, enough replication, in other words, enough sample size, some kind of control. We certainly don't have the randomization here. We're not randomly assigning babies to the treatment, which is low birth weight. So it can't be an experiment. So survey or observational study. Well, survey is where we come up with a series of questions and we're asking to collect information. This is more, there's not really questions being asked. We're observing some phenomenon. We're observing babies based on their weight and then whether or not they survive. Now here's the key to the whole study. Compare the percentage of the cases who had low birth weight with the percentage of controls who had low birth weight. What appears to be the conclusion? And we have to be careful here. I like that it says percentages because this is important. If you look, and we look at the low birth weight, there were 28 of the ones who died that had low birth weight, and 29 of the ones who survived who had low birth weight. So it looks pretty much the same. If anything, we might say, well, the ones who survived had higher birth weight, or had a higher number of low birth weight babies, which is true. But it basically looks like it's 50-50. That's misleading because keep in mind that there were 44 babies who died and 237 babies who survived. So that's why it asks us to look at percentages. And if we grab this calculator here, and we look, what is the percentage of babies who died who had low birth weight? So we have 28 divided by 44. And why am I doing that? 28 is the number of babies who died with low birth weight over the total number. And that gives me about 64%. So of the babies who died, about 64% had low birth rate. Now let's go over here. So we're looking at 29 babies who had low birth weight, dividing that by our total number of babies who survived, and we get 12%. So in other words, this is over 60% of the babies who died had low birth weight, but just a little over 10% of the ones who survived had low birth weight. So even without going through a specific, what we would do is called a chi-squared test here, even without going through that, we can tell that something's going on here. And it may be correlation. It's probably not the low birth weight itself. It's probably something connected with the low birth weight, that some organs are not fully formed or other issues. But certainly we see some kind of pattern going on here where the babies who did die were much more likely to have low birth weight than the ones who survived.